Yes, we can hear you loud and clear.
So Asif, I'm presenting on behalf of Homi Baba, and just wanted to start. We have three pillars that we enforce that you wanted us to do, and one of that is most of our code is single responsibility principle. We use the single responsibility principle, and the second part was we also had branding. So we got logos and stuff like that. So our application has that stuff. And the third part was the work was distributed and everybody contributed. Even though we had a very big team, all of us contributed.
This is awesome. Great team spirit and beautiful logo.
Okay, thank you. So used Shopify to get it.
Nice.
So then this is the technology stack, front-end React.js and Tailwind. Fast API for the microservices for the APIs. Database Postgres. Infra Docker Apache Tika. And the AI ML sentence transformers, FAIRS, BERT, cross encoders, and search Elastic.
Nice.
One more thing wanted to add was who did what, so that you know. So Madhu did the downloader and the Ray POCs. We are still not added that to this application as yet, but it's ready to go. Jai did the chunker, and he was really passionate about it. He made a lot of changes, and he knows that code inside out. But he's offline now, so we may not be able to explain that part of the code. And Haripriya did the database. Aditya did the parser, the cross encoder, and he Dockerized a lot of the components. And Prashant did the semantic search, Elasticsearch, microservices, and built the entire solution together. Okay.
Nice.
So this was the high-level architecture you provided us, Asif. And this was our database design. It slightly differs from this, but this is based on what we did. There were some changes. We had a composite key in the chunks table between chunk ID and document ID.
Mm-hmm.
So this is the high-level architecture. Just put it in a flow diagram. Any questions on this? And this is standard of what you wanted, and this is exactly what you gave us to.
So the semantic service does both the index building as well as adding to the index as well as searching the index.
That's correct. Yes.
And it manages one index file or many index files?
One index file.
One, yeah. Excellent. Okay, and how often do you save the index file? When there is an add to it, suppose a record is added to the index file, when do you save it?
So right now, Asif, this is Prashant. So the way we are doing it right now is we have a separation between offline services and online services. And offline services just do a one-time job. So the flow we have is there is a downloader which will download all the documents, PDFs, texts, JSONs, whatnot. And then there would be a doc processor, which will, like the Tika basically, would process it, convert it to text. And then this index creation would, chunking and then index creation would be done. And that's it. So we won't be, we are not dynamically checking for any new documents added or anything like that.
Okay, good. Nice. So this is the inference architecture.
That is right. Yeah.
Can I ask a question?
Go ahead.
Hey, the FAIRS index, are you storing it in files or you're storing it in database?
We are storing it in file.
Okay.
Actually, in DB, yeah. In DB as well, actually, both.
Why would you store it in a DB? Now, one question, why would you store the index in a DB? Big binary objects shouldn't be stored in the database.
Yeah.
So avoid that. Databases give you the facilities like that, like Postgres gives you. Don't do that. First of all, you'll have a vendor lock-in. And secondly, as a principle, large, big binary objects don't belong to the database. They belong in object stores.
Got it.
So keep it in the file system or object stores. Okay. All right, please continue.
So these were the challenges, environment. But luckily for us, once we built the entire Docker script and the standing up Docker script, that really helped. So now we can deploy that on any environment.
Excellent.
And the integration was another difficult part. But with the Dockerization, we kind of worked around that. And the dispersed team, that was sometimes a challenge because sometimes we worked in Zoom calls and sometimes they went away and we worked together. So we had some challenges there. But it's all working out well now.
Yeah, your team has a lot of remote people, right?
Yeah.
And must have been quite a challenge coordinating different time zones.
Yeah, sometimes we got into conversations and we forgot about the people remotely. So we learned from those lessons too.
Yes.
So we'll go to a live demo and I'll hand over to Prashant.
So let me share my screen.
Stop sharing.
Does everybody see?
Yes, we can see.
Cool thing. Okay. Yeah, so this is the GUI that Albert referred to earlier. So basically right now our core, just hold on for a moment.
No,
Just bear with us for a few minutes. Okay. Yeah. So basically, our corpus, as required, basically does not include documents all from the same domain. So we have a few PDFs that we gathered from data.gov. Essentially, it's the same set of PDFs that we had even during like the Oppenheimer presentation, right, as we were part of the same team. And beyond that, we have like some more mixed documents that have different formats, like a JSON or XML or a PDF, but they don't all belong to the same domain. So we can like put in few queries here. So let's say state of business as the first query, and we'll see what it outputs. So these are basically the 3 results that it picked out of the documents. And these results, as we've discussed over the past few weeks, are an accumulation of results returned by Elasticsearch and semantic search. And what we are doing here is we actually remove the duplicates. So we are just showing the unique results here. Are there other queries as if you want to try?
I know, just say, so here's the thing, for AI search, it's best to write full sentences. So let's write,
We are not able to hear you.
Are you able to hear me? Hello.
Yeah, okay, go ahead, please.
Yeah. So I'm trying to see. Okay, just say something like, how would I start a small business? Yeah, so your corpus is probably not big, but the search results are right in the
Yeah,
sense
it's
that,
hardly, I think right now it's hardly 10 documents as of now.
right. Okay. So no, this is good. I think your UI looks very nice. Your simple and nice. Your architecture, your inference architecture is right. And everything has come together. It's all working, isn't it?
Yes. And that I mean, a big thanks to actually Oppenheimer's architect. Basically, we got like inspiration from the way Oppenheimer's had designed the architecture, and we just extended it.
Okay.
So basically, what we described earlier about this offline processing and online inference pipeline, all of that was similar to how it was done during that phase of the project.
Yes. But
So,
to the
yeah.
extent that it is a hybrid AI search engine, you wouldn't see its power or validate its effectiveness unless you give it a good corpus. If you're having difficulty picking a corpus, then you can start with some simpler ones, like start with the whole Wikipedia, which is very easy to download. If you want, they are available as Parquet files from Kaggle, for example. You can try the Wikipedia itself and search through it. Apply
Sure.
your technology to that.
Sure thing. Yeah.
Yeah, certainly do.
Wonderful. And do you want to talk about your inference, the producer pipeline?
Sure. So give me a moment. I'll share another screen. Yeah, so essentially, this is the entire setup. So we have basically offline services, which, as I was mentioning earlier, has the downloader, which is essentially the download.py file, a doc processor, which uses the Pachetica to convert it to text, and a chunker, which, as Albert mentioned, Jay did a lot of work on, which
Nice.
semantically creates chunks, appropriate chunks.
I would
And
like
these
to
are,
see that. Show me any one thing, any one implementation in Python.
okay, let's go to the chunker.
Okay. Oh, this is a pretty extensive implementation. Very good.
I think so. Jay has put up a good effort over here in terms of researching how he can make Chunker better over time as well. And he's still not stopping. He's still going through and figuring out what thresholds or what kind of numbers which we are putting in over here, how much percentage of data we are losing, and what it does to our chunks as well. So kudos to Jay on that front.
Yeah, we wish he
Yes,
was
so I
here
can
and
see-
explain this
I can
code
see.
because
Yeah, I
Yes.
can see. I got the idea of the code because I think I have a sense where it's coming from. This is excellent work, by the way. You're using clustering. You're also using data cleaning, and you're looking at the cluster sizes and subclusters if needed, which is all very good. This is really good approach. Continue down. See, there are only a few good, well-established approaches, and this code that you're showing, I think I know which approach it belongs to. It is well done. There are a couple of minor feedback I will give you guys on the code. First of all, it's very good. It's a lot of very good work throughout. The couple of feedback, which is more or less the same to all of you. Three feedback I'll give you. See, two feedback actually. One is that when one of the three events happen, you do IO, you do model inference, or you do RPC, remote procedure call. All of those actions should have what? Do you remember? Logging. Yeah, they should all have logging, and they should belong to try except block, exception handling blocks. So that is essential. That is quite essential, like 110. How do you know that file exists and file is readable? You wouldn't know, right? So if it fails, it will throw not very clean exception. So you can do exception formatting and beautiful things and print very useful messages. In production, it matters. The time to root cause analysis matters a lot in production. Right? So it is important to do that. Please bring in exception handling and logging. See, most companies, most people don't do that, which is why they suffer. A code is like, the time to build a car is finite, but a car lives for 20 years or 15 years. The same is true with code. A code has a decade worth of life, but it is written in a matter of weeks. You need to, as a courtesy to the people who are going to own it for the next decade, have a lot of comments, type hinting, exception handling, logging. It makes everybody's life easy. One consideration that I would advise, add type hinting. So my second feedback would be add type hinting. For example, a PDB. If you look at line 103, PDB, what it refers to, of fast. So from the context, people can infer, but it is much better if it is declaratively stated what these things are. But other than that, this is very good code. Please continue this. It's very well written. Nice job.
Thanks for the input, Asif.
Anything that you want to show?
This is basically the offline services. Beyond that, we have the online services, which has AI service, which is essentially the microservice.
Is your microservice written in Fast API or is it written in Ray?
Right now, Fast API. We are
Transition to
experimenting a few things with Ray. If we get a handle on it, then we'll explore more with Ray on this front as well.
Yeah. Ray is almost a deregulated. See, one AI framework, whether it's Ray, MLOps, it is a Kubeflow, etc., etc. Pick one. Ray is a pretty good choice, but pick one and use that. When you just use a general purpose microservices framework, like for example, Flask or Fast API, then you forego many of the powerful features that AI serve frameworks bring. So I would suggest that. And I know that you guys are already doing, I think you just mentioned that Madhu already has a proof of concept, but in the coming weeks, please go full blown with any one AI framework. Choose Ray because Ray seems to be the choice of everybody here. Pick one, you can get help from other teams.
Yeah, we have Sachin here too, and he's ready to kind of assist for Ray.
Okay. All right, please continue if you have anything else to show.
Yeah, so that's essentially a microservice essentially handles, what it does is it gets the queries from the UI, it forwards it to the individual module. So Elasticsearcher, the semantic searcher, which get their individual outcomes, and microservice then forwards that to the cross encoder. And essentially we pass it through mini LM model.
And where do you keep your configuration information, the location of the services and things like that? How do these services know where the other services are? How does that, for example, your main microservice know where the cross encoder is?
That is the main microservice. Yes.
It's all happening.
Or you have hardwired it in the microservice. Try to
externalize. As of now, yes.
Externalize it to a configuration file. Pick your format, any format, YAML format, JSON format, key value format, whatever you like, but externalize all of your configuration. It should never be in code. But for now, it's good because see, your team started late. So they are practically, you have a disadvantage of almost 10 days. It will take you a little bit of time to catch up, but you guys have done an admirable job rising up to the occasion and putting it all together. But in the next time, let's say in a week or two, try to externalize it to a file.
Absolutely. Yeah. And front end is basically the UI, the beautiful UI
Yes.
that we were looking at. But
Nice.
and all of them are Dockerized. So as you would see, each of them have their own Docker file, and basically we just use a Docker Compose to fire up each of the containers and create that sequence, get it going.
Since you guys are getting into Docker, if it is a new experience, if you already are gurus of Docker, I won't say anything. But if you're getting into containerization, do give Podman a look.
Podman.
Podman.
I think Sachin is experimenting with Podman as well. So yeah, we will try to see how we can implement that.
Okay. And one more thing, bring up Cockpit. I didn't do it on your machines. Bring up Cockpit.
Asif.
Cockpit is a Linux application.
Okay.
What it does is it gives you, you'll realize why I'm asking you to do Cockpit and Podman. And when to manage Podman, you may look at Portainer. Portainer manages both Docker and Podman very well on the machine, on the server. It just makes it very easy for you to see what's running, what's not running, gives you a dashboard.
Okay, Cockpit is for that.
Yeah, Cockpit gives you Cockpit. You can look at an entire cluster and see it. And Portainer, again, helps you manage containers and see what's going on.
So Asif, the box that we got, is it a GPU thing or a CPU box?
No, this is a pure CPU thing, because at this moment you're not fine-tuning any model, but soon you will have the access to the inference server the moment you start fine-tuning.
Okay, thank you.
All right, guys.
So yeah, that's all that we had.
So